Hey everyone, thank you for joining the EDX SignalPro Auto Router webinar. My name is Rory Fox, and in a moment, Bryant Jones will be walking you through the automatic site selection features for both area-wide and fixed multi-point networks. We're going to walk you through the process for using SignalPro to quickly find an efficient solution for covering a given service territory or group of fixed subscribers, given a set of candidate site locations. If you have any questions for us during the webinar, you can type them into the webinar panel and we will answer them at the end. Now I will turn it over to Brian Jones.
Hi, thanks, Rory, and thank you to everybody for joining me today. Like Rory said, today I'd like to take you through our automatic site placement tools and to basically show you the commonality in how you can use this tool for finding site or gateway locations for an area-wide mobile nomadic type of network or a multi-point network. And in fact, these same rules apply to mesh networks as well, and the tools you have available are very similar. I've got this PDF I'll be working from here today that we'll make available by a download link after I've finished, so that you can download this and use it as a guide for running through this process yourself. And like Rory said, we'll open it up to questions at the end. So as I'm going through this, if there's anything that's not quite clear, please keep track of that and let us know at the end by typing it into the chat window. And so the automatic site placement tools, the idea is to speed up the overall design time when you're presented with a polygon area that you need to cover or a fixed number of fixed subscribers for point to multi-point that you need to cover. We want to be able to go through and choose the different candidate sites in an efficient way so that we're not using too many sites to cover the area. But in order to do that, traditionally, what people would often do is to go through and run an area study for every candidate site that they might consider and sort of overlay the coverage plots of them and figure out which ones they want to use on an individual basis. With the automatic site placement tool, we're going to do that in the background, running the coverage footprint of all of the various different candidate sites, and then using an automatic placement routine to try and find you an efficient collection of those sites to serve your needs, both in terms of connectivity, but also capacity as well. And without having to do a bunch of manually running of studies and overlaying and choosing on your own. So I'm going to get into this document, which sort of takes us through the process here. And each of these bullet points in the PDF is a step that you'll need to perform as you go through this. So let me jump over to my SignalPro project here that I'm using as an example, and just show you what I've got to start with. So before I started this process, I first go in and plug in my terrain and land use, land cover databases. And so I've got high resolution terrain, and this is out to the west of Denver, Colorado. So you can see I've got some valley floor here and then getting up into the hills. And this blue polygon is the area that I need to serve, or the area where my subscribers are. And for land use, land cover in this project, I'm using our EDX Cirrus database. So I've also got very high resolution land cover data that I ran this project based on, which apparently I need to set up that database. I'm just using this example for visuals to show you the dialogue. So I've got another example here I'll show you in a minute. But the first step here, once I've got my environment set up, so I've got terrain and clutter, and I have a propagation model that I'm happy with. And you notice you can set up multiple different types of propagation model, which can be useful in this process if you've got a very large area. I'll get to that in a moment. But once I've set up the basics of my project, I'll create a site template that's got the default details, my operating frequency, my height above ground level, my transmit power, etc. And I'll set that up for a template site or a template gateway location. And I'll also set up a typical subscriber unit. If we're talking about an area-wide project, this will be a mobile remote unit that I'll define its height above ground level and any antenna gain and that sort of thing. And so that's what the link budget will be based on, that the automatic site placement is going to run from. So if I'm doing area-wide, it's going to use the site template that I've given it and the mobile remote unit that I've given it. If I have fixed subscriber locations, then I'm going to define my CPE, or customer premise equipment, and I can define different types of CPE that have their own antenna gain and height and so on. And then I would import those through the CPE spreadsheet so that I've got a list of fixed subscribers like this on the map. And what I'm going to show you as I go through this is whether you're starting with a list of fixed subscribers or a polygon area you need to serve, the process is largely the same for running this automatic site placement. You just find it under a different dialog. So now that I have the area I need to serve and sort of my link budget set up and my subscribers, the next thing I need to do is set up the candidate locations where I could place a gateway site. And that's going to be under the databases, towers, and poles. And this is a simple CSV table that gives the obviously a unique name and then a mounting height and an overall height for each of the pole locations, along with its latitude, longitude, location. And this can also include a relative cost for that site. So the classic example is if the utility poles are cheap or free for me to deploy on, but I also have access to cell towers if I need them, then I can put those cell towers in with the utility poles in my tower and pole database and give them a higher relative cost. And we can talk about how that cost might figure into this down the road. But this pole database should be a definition of the precise locations and heights of all the potential mounting assets that I could use. Now, if I don't have that from my customer and I need to sort of fake it or get an automatic site placement without any starting locations, that's where this create points tool becomes helpful. We can either create a grid of tower locations at some uniform spacing, or we can create the towers at some spacing along the streets. So we'll base it on your GIS data, and you choose whether to include streets and major roads and highways, and it'll place towers along those streets to use as candidates. And then we also have a filtering function here where oftentimes your customer might give you a list of pole locations that'll have, say, millions of devices in it, and you need to filter that down to just your area of interest, or filter it down so that you've got, maybe a pole every 200 yards or something like that, so that you can strip down the list of candidates to something more manageable. And that this filter function will allow you to do that with your input tower file and save a smaller tower file to work with. Once I have, and the last thing I wanted to say about this is you can import these tower locations from a Google Earth KML of points, or from a CSV table that you've got, where you would just go in here and point to your CSV file and then assign which column in the table corresponds to which value here, and you can import it very quickly. So you shouldn't have to spend a bunch of time formatting your table just so. If you use this import dialog, you can import from just whatever CSV spreadsheet you're working with. And once I have brought in those tower locations, if I go into my map layers, I can add a layer called towers here. And I'll go ahead and check that on so I can see it. And I've set the color and symbol to make these little blue points every place that I've got a candidate pole location. And you can see they're pretty dense and regular down in the valley here. And then they start to just closely follow the roads and get pretty sparse when we get up into these hills. And so this is what I have to work with as far as potential gateway locations. And let me move on to the next slide here. So again, we set up a boundary polygon and set up the study area, import that pole database or create it, filter it down to make sure it's a reasonable number of poles, and then I should be able to see those on the map. And like I talked about before, I've set up a propagation model and options that I can use for the automatic selection. And for larger projects, one of the strategies that you can use is to set up a faster propagation model, something that just runs really quickly because it's not looking in as detailed a way at clutter and terrain along the path. And you can use that fast model for the selection process if you have an extremely large number of poll candidates or an extremely large area that you need to cover. This can allow you to do the auto selection with a less rigorous propagation model, but do it much more quickly. So that especially in dense urban areas where maybe the selection is going to be more affected by capacity than by connectivity, it makes sense to run a faster propagation model and let the capacity be the important part of the auto selection. So I've already set up my models and I've already set up my site templates, so I can move on past that. And now the next stage here, so I'm all ready to go into the auto placement function. And in the first example, I'm going to look at the auto placement for areas. And when I open this up, I get a big dialog with a bunch of options here that I'm going to go through that from top to bottom. And again, this PDF that we'll send out after the fact has this breakdown if you need to go back and review later. So when I go into the network design analysis menu and use the auto placement for areas, so this presupposes that I have some module under network design analysis that enables this function for me. And here's that big setup dialog that, again, we kind of want to go from top to bottom and address all the items. The propagation selection, this selects which one of the models you're going to use just for the purposes of the site placement, not necessarily the finished coverage prediction. And so I've chosen to use my global group model 1, and I've given it a lookup spacing of 30 meters. Now, if I had a huge number of poll candidates and I wanted this to run faster, I could set a more coarse point spacing, and each one of those path calculations will go faster just for the purposes of auto placement. We can also use this building height if I have a building database in here, which will put the receivers on rooftops of buildings for the purposes of auto placement. The next thing I do is set up the list of candidates that I'm going to use for towers. And like we talked about, I'm using my towers and poles file that I've created. So I just check this use poll database. If I had already created a bunch of sites in my project and I want to select a subset of those, I can use an existing transmitter group instead as the candidates, and it'll try and filter that down. I can also give this a new group name for the transmitter group that's going to be created. And here's where I select which of my mobile remote units. Again, since we're looking at the area-wide case here in auto placement for areas, I select a mobile remote unit to act as my subscriber. And this part is important here. I've got set up sample grid for area because I'm looking at my area study grid, which I've extracted the study area and I can view it. And this sample size reduction, this is going to take the grid points and in your study grid and subsample them just for the purposes of the auto placement. So I've got an 8 here, which means that for a square of 8 study grid points, it's going to count those all together as one location. And if it has coverage to that one location, it'll assume that all 8 of those points are covered. And this is how you scale the speed versus precision of the auto placement routine. If I leave this set at a 1, it's going to use every single grid point as a subscriber location it needs to serve, which may be overkill just for the purposes of finding gateway locations. If I increase this, by a factor of 2, for example, it should run twice as quickly because it's only calculating half as many points. And so for a large area study grid, I can sample this down a fair amount, and you'll notice it gives me a new sample size number here. This is the number of points that are within the study grid at this new sampling. And you can see I've when I talk about this in the PDF here, I usually aim for a sample size at this stage between 100,000 and 300,000, just as a rough guideline for what will run in a reasonable amount of time. That's usually where I aim there. But then the next thing is to point to that service area polygon. And let me jump back here. Once I point to my polygon area, which is just a subset of the grid, I can hit this test filter button, and that'll give me the number of study points that it's actually going to try and cover. And in this case, it's 67,000 and change, and that's less than that 100,000 benchmark. So I feel like this will run in a reasonable time frame, even though I'm using my fully rigorous, Anderson 2D propagation model. So at this point, we hit the run auto placement calculation, and it gives us some more options. Again, I can come in and set the group name that I'm using, and I set the template for the routers that it's going to create. And now I've got a router range and service threshold here that this is the maximum range that it will consider that router to be able to have any coverage. And if I set this down to a very short distance, the gateway assignment will run very quickly, but it might overlook potential coverage of those sites because, maybe the site covers further than 2 kilometers. So this is one way you can scale things to go faster or be more rigorous as well. And then I give it a threshold that's the signal level I'm looking to achieve across my entire study area. And in this case, I just put in -100. We'll assume it's a fairly low data rate, robust sort of radio. And now we have 4 different methods that are available here. And the coverage limited selection, you just simply give it a target percentage, and it'll go through and try to hit that percentage of coverage in a fairly simple way. We've had this method in place for years, and some folks use it very happily. The method 2 additionally lets you put capacity constraints on this. And this is more appropriate probably to multi-point type of projects where you have a fixed number of subscribers and you give it the number of subscribers that one gateway can serve, and this will assign enough gateways hopefully to cover the study area at the target percentage and also not have any overloaded gateways. This method number 3 is specifically for RPMA type assignment, where their assignment is based on the number of servers, uplink servers. And so we have a different method specifically for that. And then the method that I really want to show you today, the one that we're excited about and is applicable to a lot of different use cases, is this method number 4. And whether we're talking about area-wide or multi-point networks or even our mesh networks, this method number 4 is kind of our best performing gateway selection tool right now. And it's got a lot of bells and whistles on it. So let me go through those real quickly. So just to review, I set up the area and the number of sample points that I'm going to use. And then I jumped into this method, or jumped into where I select which method I'm going to use it for. Oh, and see, this part is important up here too. The use installed routers checklist. This is so that if you have an existing network and you're looking to expand it, it will use those existing sites that you've already created and take them as already installed, and it will select from your candidates list routers to fill in any uncovered areas. So if I check on this use installed routers and select a transmitter group here, it's going to assume that I already have those transmitters on and operating, and it will only select more routers if it can fill in areas that are not covered by my existing routers. So again, this is useful for filling in gaps in the existing network or planning expansions. But if I'm doing a greenfield project, I leave this turned off. And again, method 4 is the method that we really want to show off, and that's the one that I'm really here to recommend that you try today. And so once I get into my optimized capacity planner dialog here, we've got those same parameters that I set up in the previous dialog have been pushed forward here so that I can modify them for subsequent runs if I want. And again, if I was doing a fixed point to multi-point design, maybe I put the number of fixed subscribers that a given site can support as my maximum router capacity. As it is, we're looking at the area study grid, and so I've just set this number up to be essentially all the study grid points within the service area, so that if one site can cover the entire grid, well, hey, use that site, great. And then a minimum router capacity, that allows you to set a minimum number of either fixed subscribers or area covered by a gateway. And if it can't even achieve that, we just won't bother with it. The important thing to look at here for setting up and running this is over on the right, we've got these stop conditions. And we can ask the software to stop this when it gets to a certain sector count. So I can say, you know, find me the best 10 sites out of this list of candidates and propose those as the sites. Or we can say, stop when you get to 90% of the area covered. And then we also have this stop on total cost, which brings me over to this planning costs idea here. And just at a high level, if you have put relative costs of the different tower and pole assets in your pole database, you can set up the software to look for the best bottom line cost rather than the fewest number of gateways. And in order to do that, you turn on this use costs for planning and you configure some of these numbers. And then if you want, you can have it stop when it gets to a given total relative cost for this set of gateways. Since I just want to do the simple case here, I checked on this stop on percent coverage, and I also give it a TX separation, which I set this down fairly low so that it would give every candidate location a good shot. When this starts out, it starts out by pre-choosing a collection of candidate routers and calculating them first. and the distance between those is set by this TX separation. So these values in here, you should not have to tinker with very often, but if you want things to run more quickly and you have a very spread out network, you might increase this value to a higher TX separation. For my purposes, I generally leave it down at the 1 kilometer, or even finer if I'm doing like a small microcell area. And when I click this Run Optimized Capacity Planning button, it's going to go through and calculate how much of the area can be covered for each one of those candidate sites that it pre-chooses, and it's going to go through and look for a best selection. And of course, running those propagations is going to take a minute. So what I'm going to do, just like I've got a cooking show here, I've already got another instance of SignalPro open where I've already pre-calculated this. And so I ran my optimized capacity planner here, and it has proposed this list of sites. And you can see down at the bottom here, it says, do you want to keep 25 new sectors having load? And this is the number of study grid points that it can serve. So this is not real useful in an area-wide example, but if this were a fixed multi-point, this is telling me the number of subscribers that can be served by this collection of gateways, which in this case is 91% of my service area. And I had asked it for 90%, so it's doing pretty good here. But I can subject this solution to some human intelligence here at this stage. If I turn on this X toggle mode, then I can toggle sites on and off. Maybe I'm looking at this pole right in the middle here, and I want to know what happens if we don't create that site. So I can turn that one off, and you can see it recalculated really quickly. And now it's saying we're serving 88.94% of the service area. And you can see my color map up here is showing the poles to the north and south have picked up most of the coverage area, but not all. So if I turn this back on, then I can see the small coverage footprint that site's got, and I'm back up to my 91%. Well, and so what happens if I take this one out here? How do its neighbors fare? And now we're back underneath my 99% metric again. So this allows you to kind of go in and say, oh no, I don't want to put a gateway there. I'll fill that in some other way. Or, you know, you can subject the solution again to sort of some human intelligence. And that means if you want, you can also ask it for a higher percent coverage goal with the intention of going into this and maybe shutting some of the sites off, you know, based on your own observations. And when I'm happy with this solution, and it's kind of nice here because it's a non-destructive thing. If I turn off several of these and say, okay, this is actually the assignment I want to go with, I can choose any of these solutions that I looked at while this dialog was open and say, well, I'm going to go and use this one. That's the one I really want to keep. And when I click yes, it will go ahead and create those sites as a transmitter group that I can then go back and run studies on. And so this kind of gives you the best of both worlds, having the automated process propose a collection of routers, and then you can decide if you want to turn some of those routers off and move forward with that selection. And so at this point now, I've got routers to cover my whole area, and I'm going to go ahead with the initial collection that it really offered me. And again, I calculated this once before, so let me just back out of this. And once it has created the sites, and you'll notice it's given the site names as pole 1460, 1178, etc. These names are coming from the tower and pole database. So when I create my CSV table with all the utility poles that I could use, they have a pole identifier in there. You know, I've got a unique name for each of those, and it's pulled those names over into the site so that I know, you know, which asset I used and created these on. And as you recall, when I did the automatic site placement, I subsampled this area study grid so that I was using 8 study points to represent 1. And so that area placement was not done on a completely granular basis. So the next thing I want to do is set up and run a regular receive power at remote area study at full resolution, full granularity for this collection of poles. So I would go in here and choose the transmitter group that I placed and run this area study just based on those sites. And I think I've still already got this calculated. Yeah. And maybe I set up just a couple color levels. Since I was just only interested in which devices are above or below that -100 threshold, maybe I'll give myself a color scheme like this. And then if I go up to my study query tool, I can take a look at this area study, and again, using my same service area polygon file here, I will run a query against that, and it'll tell me what percentage of the area is actually passing that -100 dBm criteria. And when I go and look at every individual study point, I see that in this case, I'm actually serving 93% of the study grid points, as opposed to the 91% that we came up with when we were running the less granular automatic site selection. So that's a good way to go back and sort of prove the results and make sure that you're meeting the criteria you're presenting to your customer. And the other nice thing about that is once I run this query, I've got the contribution of each of these different sites to the overall coverage footprint. So I could go through here if I wanted and see which sites are contributing the most to the overall coverage and which sites are contributing the least. And, you know, maybe this site is one that I can consider for elimination, especially if I go back and find that maybe my propagation model is a little bit conservative or something like that. And so in this way, you can make sure that you're hitting your target performance criteria across the whole service area. Or, you know, like I said, if we jump back over here to this project that has some multi-point sites in it, I auto created some sites for multi-point here, and I did the same thing with the automatic site placement for areas. If I wanted to go in and do this for multi-point, then I go to network design analysis, and instead of auto placement for areas, I choose create hub or transmitter group under the multi-point menu. And that gives me a very similar setup dialog. I want to go first to the automated router selection. We've got this old hex placement method here that's still available because some of our users still use that, but the automated router selection is the new method here. And I set up my propagation just like before. I set up my router candidates just like before, use the poll database. And then the CPE list, we can either use all of the CPEs in the service area, which I already have imported, or we can do an exclusion distance and sample together clusters of CPEs. So in other words, if you had an apartment building where you have a whole bunch of subscribers that all essentially have the same latitude, longitude, location, we can cluster those together based on this distance to each other and treat those as just one sample point with a traffic value of however many CPEs are included in that. And in that way, it'll cause the automatic placement routine to run more quickly because it has fewer individual path profiles to run. I want to go ahead and just use the entire list. So I would just jump right to run auto placement calculation. And here again, we've got those same 4 methods that I can choose from. I have the ability to turn on or off installed routers. So if I've already created a bunch of routers, I can use those as a given and then look for candidates to fill in the rest of the subscribers. And again, here, the capacity planning method 4 is the one that we would recommend. And you can choose those same stop conditions. And you can also set a maximum number of subscribers that can be served by a given gateway. And it'll go through all the potential possibilities and propose you a set of sites, which is how I came up with these sites here. And when I go and run my query in this case, since it's a multi-point study that I've set up, I go into study point queries, go to multi-point study. And when I run this, instead of a list of coverage percentages, what it gives me is a list of each subscriber in my CPE list and which gateway it should be talking back to, what the server result was, azimuth and elevation back to that server. And of course, over here on the right, I get the percentage of subscribers covered with this set of gateways. So the process for either auto placement with areas for an area-wide or a mobile nomadic, it's essentially the same as the process for multi-point create hub and transmitter group. The only difference is whether we're using the study grid points within the study grid or fixed subscriber locations as those target locations that we're trying to serve in the automatic placement. And of course, the one final thing that I would say about that is if you're running the mesh network module and you're doing a large mesh network, you've got that same automated router placement tool in here. So if I go into automatically calculate router locations, here's that same method for, oh, I guess I have to give it a name. Here's that same method for with the same setup parameters. And here we're talking about the number of mesh nodes served by a gateway as opposed to fixed multi-point subscribers or area grids. So if you learn to use this method number 4 automatic placement, you can really use it for just about any use case, possibly with the exception of RPMA IoT, which would then use this method number 3. And that has a very similar dialogue to set it up. And the only difference is kind of the algorithm and the criteria it uses to assign gateways is a little bit different under the hood than this method 4, which is more generalized to any technology type, any frequency band. So let me jump back to my PDF here. We set the stop conditions on the gateway placement. I check my range and threshold settings over here and set the coverage limits as far as how many subscribers I can support or how many study grid points I can support. And then I click this Run Optimized Capacity Planning, and it's going to give me its proposed solution. And I can use that X toggle button to turn some of those gateways on and off. And then I go out and I run my area coverage study and run that query to see what the actual coverage metrics are for the proposed solution. And at that step, I'm ready to start producing reports to show to my end user or my customer about what the coverage is going to look like for this proposed set of routers. And, you know, hopefully that process should not take me long to set up or to arrive at a good collection of gateways. And I should be hard pressed to come up with a better solution by manually choosing out, sites. This should be just about the best solution that you can find for that service area and that group of candidate sites. So I know I went through that pretty fast, and I'll send you this PDF to be able to review that as you go through. I'd like to go ahead and open it up to questions now. Rory, have you had any questions come in over the chat?
Yeah, so there's a question here. How does this process change for multipoint or mesh?
Right. The main way that it's going to change is in the multipoint case, I will use every fixed subscriber that's in there within reason. If you get up to hundreds of thousands of subscribers, it might be really worth it to go in and do that subsampling. And so the main difference is I'm going to go into multi-point backhaul networks, create hub and transmitter group, and then I want to go to automated router selection here. And that's where my setup starts. And again, if I do have hundreds of thousands of multi-point subscribers or hundreds of thousands of poll candidates, it might be well worth it to subsample those down by putting in a reasonable cutoff distance here. And then you do this reduced CPE size by sampling, and it'll go through and make you a sample file. If I am doing an area wide instead, the main sort of conceptual difference you want to think about there, and maybe I can make this a little bit more visible, the difference is going to be that it's the area study grid points that we use as the target receive locations. So let me just go in here and put some grid lines in here so we can see them. And if I zoom in, perhaps a little closer than that. So here we can see, I'm going to turn this terrain off. Here we can see that there are individual little grid bins or pixels here that I've set up as part of my study grid. So when I go define the study grid and I set a grid point spacing, this is a 5-meter spacing. So each one of these little study grid bins is a 5-meter wide area that we're considering, or we're assuming that there's one of these mobile remote units sitting in the middle of that subscriber area. And we're treating each one of those as a target location. So when you're running the auto placement for areas, especially if I've got a really high resolution 5-meter grid like this, I'm probably really going to want to go in and sample that area down. So I'll put 4 or 8 as a sample reduction multiplier in here to get that number of target locations down into the hundreds of thousands. You notice that's kind of my cutoff, where if I'm getting up to 400,000 target points or so, I just don't want to wait for that many path loss calculations. So I'll sample this down, and it'll take chunks of these study grid points instead and make one chunk of 8 points as a target location instead. And that's really the main difference between what the algorithm is doing under the hood. It can either be looking at these uniform points and trying to fill in the entire coverage polygon, which I've defined here with this blue service area. Or in the case of a fixed network, it knows the exact list of those fixed subscriber locations, and it's not going to worry about the rest of the service area. It's only going to try and connect to those subscriber locations. And so it's never going to assign a gateway in here where there are no subscribers. And the same goes with a mesh type network. If you're running mesh studies, the first thing it does is go through and pre-calculate the mesh so that it knows how those mesh nodes interconnect. And then it's going to assign gateways on the basis of connecting up those mesh nodes, and it'll ignore any part of the service area that doesn't have any subscribers in it. Do you feel like that was clear, Rory? Do you have some other questions?
Yeah, there is another one here. So, what will happen, or what will the software do if there's just no solution that's going to get us to the target coverage percentage?
Yeah, so what you will find sometimes is that there's two ways you can get an insufficient answer. If you just don't have enough candidate locations, and let's say, out here in the mountainous area, there are some of these areas that are never going to be covered by the candidate locations I have. And so, if I asked it for a 99% coverage, it's going to come up with the best it can do. And maybe it'll tell me, well, I can serve 95%. And it'll give me a whole bunch of sites to try and serve that 95%. But that's the first way you can get an insufficient result, is where it'll make a proposal, but the percentage coverage doesn't quite reach that stop condition that you had said or set. And that's basically telling you, well, this is the best that it can do. The other way that you'll sometimes see is it'll pop up a dialog that says no useful routers were found, and it won't propose anything. And what that indicates is that you've set something up wrong. It means that it looked at all of the candidate sites, and none of them could contribute any new coverage to the solution. And usually what that means when I run into that message is either that the candidate sites are in the wrong place, they're out of the study area or something like that, or more likely, this use installed routers in the selection process. If I have that turned on and I already have some sites that I'm using as pre-built, then that no useful routers were found message might pop up because none of the candidates that I gave it were in a location that could contribute any new coverage to the area. And so that's one of those cases where you might think you have something set up wrong, and you go to run it and it says no useful routers were found. And the reason why is because none of those new candidate sites was actually able to cover something that the existing sites don't already have covered. And those are really the only two ways it can fail or produce an incorrect result. You'll either get no useful routers, or you'll get some routers proposed that may just not reach your the criteria you're going for. And in that case, it might be worth looking at going back and increasing the number of possible candidates in your tower and pole list. Like if you had subsampled that down, maybe back out some of that subsampling and use a bigger list of candidates to see if you get some that'll serve better. Does that answer your question, Rory?
I think so. One more that we just got in. Is it possible to set multiple sites at the same locations, but with varying heights or powers?
Yes, you can. So the automatic site creation is going to always place gateway locations using the same site template. So the transmit power on the gateways is going to be the same for the purpose of gateway placement, no matter what. So it's really only selecting locations and not equipment for you. However, I have seen the case a couple times where you can mount at one given height for cheap or free, and if you want to go up to a higher height on the tower, that's going to cost you more. And but the tower location is the same. And in that case, you could put both of those pole locations in with a different height. The software is keeping track of the locations as an XYZ coordinate. so that they're considered distinct locations if they have different heights. And so you could give the higher slot on the tower a higher relative cost than the one that's lower down, and in that way, it's only going to select that higher location if the cost, the number of extra devices served outweighs the additional cost for being up higher on the tower. Does that answer the question?
Yeah, and so with that, what you're saying is you would actually add that into the poll database before you import that?
Right. When you set up your list of candidate poll locations, you would include both of those heights as unique entries in the poll database, so that it'll evaluate each of those XYZ locations as a potential gateway. And from the from the lower spot on the tower, you'll be able to reach a certain number of subscribers, and from that higher location on the tower, presumably it'll be able to reach a larger number of subscribers, and it will only choose that higher location if the cost of those unconnected subscribers outweighs the extra cost of the the more expensive location on the tower. Does that make sense?
Yes, absolutely. So I don't see any more questions coming in here. For If there are any further questions, you can reach out to support@edx.com, or Brian, if you want to field any questions going forward, is that the best way?
Yeah, absolutely. You can email support@edx, or you can always email me directly with questions at brian.jones@edx.com. We would love to get your feedback on the types of use cases that you're using this automatic router tool on, and we'd love to try and help you leverage this tool in your own projects more successfully. So if you're getting into working with this, please do reach out to us and let us know how it's going for you.
Well, excellent. Thank you, Brian, for presenting today, and thank you everyone for joining the webinar.